Bonjour, and welcome back to another episode of T.E.D Mini, where together we'll be learning about technology, engineering and design. In today's episode, we'll be learning about electronic components. Let's start from the most basic electrical and electronic components, which are power sources. In general, we have two kinds of energy sources, which are non-renewable and renewable. The sun provides our planet with all the energy we need. Plants and animals store some of that energy even when they die, and after thousands of years, the remains become fossil fuels. Fossil fuels are a very bad energy source for multiple reasons. First of all, they are non-renewable, which means that once we finish with the stock we have on Earth, we'll not have any more to use until many thousands of years more. They also produce a lot of greenhouse gases, which are incredibly bad for the environment. Hence, where renewable energy sources come into play. These kinds of sources provide energy which can quickly replenish themselves and can be used over and over again. A good example of a renewable energy source is the energy from the sun, or solar energy. We can capture this free energy by using solar water heaters to capture its heat, or solar panels to convert its energy into electricity. We can use the movement of air or wind to turn wind turbines to generate electricity, or turn old-fashioned windmills to grind corn or wheat to grind flour. The movement of water in tides or rivers can be controlled using dams to create hydroelectric energy. All these energy sources can be used to power the wall sockets in our homes and schools. In America, the electric voltage in wall plugs is around 110 volts, while in Europe it was typically 220 volts, but has now become 230 volts, which is what we use in Malta. The wall socket is known as a primary power source. Secondary power sources would be rechargeable and non-rechargeable batteries. To change from one voltage to another, for example from 230 volts to 5 volts to charge a smartphone from a wall socket, we can use a power supply. And finally, to collect the energy from renewable sources such as the sun, we can use a solar cell. Many solar cells can be connected together to form a solar panel. The next area of electronic components we'll be exploring will be that of capacitors. The capacitors we will be using in our electronic circuits are generally small cylinders or flat discs with two terminals coming out of them. Capacitors are used to store electric energy inside them with the use of an electric field. We don't go into too much detail for now, but think of them like very small rechargeable batteries which can both charge and discharge very quickly. How much electric charge can be stored in a capacitor is called capacitance, which is not that difficult to remember. Capacitor, capacitance. Just like the basic unit of measurement of length is meters, the basic unit of measurements for capacitance is farads. It was so named after Michael Faraday, who was an English scientist who did a lot of research on electromagnetism, which is basically the same technology used by the capacitor to store its charge. Going back to the main topic, capacitors are quite hard wearing and can last for quite a long time. However, they have one element that can damage even the newest of capacitors, and that is overvoltage. On one side of the capacitor you will find three important markings. One is the amount of charge or capacity of the capacitor, and it is generally written in microfarads as the amount of charge is so small. The second is the maximum DC voltage the capacitor can take before being irreparably damaged. The third is the negative pole sign. This is only found on one of two types of capacitors. There are either polarized or non-polarized capacitors. Polarized capacitors have a positive and a negative terminal, which need to be connected correctly or the capacitor will be damaged. Non-polarized capacitors do not have this problem and can be connected any way around. Moving on to our next area, where we'll be looking at two types of sensors called LDRs and thermistors. LDRs short for light dependent resistor. These are generally flat disk components with some sort of squiggly line going across them. This line is made of a material which is light sensitive and changes its resistance according to the amount of light falling on it. Some LDRs are made to increase resistance, while some are made to reduce resistance according to the amount of light falling on them. Thermistors, on the other hand, are generally discs or probes, with also two terminals coming out of them. However, as the name suggests, they deal with thermal energy. In simpler terms, they change their resistance according to the amount of heat that surrounds them. Our fourth area is that of actuators. An actuator is a component that has some form of movement when given a signal. A good example of an actuator is a motor, which creates a rotational movement when electrical supply is connected. A relay switch is another common example of an actuator in electronics. A relay switch is made up of an electromagnet on one side, which quite simply is a coil of wire, which acts like a magnet only when an electric current is flowing through it. On the opposite side of the relay is a switch with a magnetic contact which opens and closes the switch when the electromagnet is turned on or off. When would such a component be useful, you ask? Well, imagine you are driving home and want to enter your garage, which is opened and closed by remote control. When you press the button on your remote, the signal goes to a small low voltage circuit, which decides if to open or close the garage door. As the circuit is low voltage, for example 12 volts, it will not be able to provide enough energy to open a big heavy garage door. Because of this, we need a big strong motor which is connected to the mains electricity. So what happens is that the coil side of the relay is connected to low voltage controller, while the motor is connected to the 230 volt motor, so that the circuit can control when the motor is on or off easily now. The relay is making it possible for the two circuits to work, with different voltages controlling each other. Speaking of coils, a solenoid is another use of a coil, whereas a metal bar is placed in the middle of the coil and made to move backwards and forwards by changing the polarity of the coil. Solenoids are frequently used in electric door locks where the lock can be opened remotely, for example from an intercom screen 5 floors up in a block of apartments. Next, we move on to our final area, which is that of connectors. Connectors are used to secure and transfer power or data from one area to the next, or from one device to the other. Jumper cables and ribbon cables are two such components. Jumper wires are generally single wires connected to male or female pins at each end that enables us to connect two power points together without soldering. When many of them are connected together side by side, they are called a ribbon cable. These are commonly used in breadboard circuit prototyping or testing, as they easily and securely slide in and out of a breadboard. If they are to be used on a printed circuit board or strip board, a more secure connection source such as a screw terminal may be needed. Screw terminals need to be soldered onto the strip boards or PCB permanently. However, the jumper wires can be slided into the individual terminals and held tightly in place with the use of a screw. When the connection is no longer needed, the screw can be untightened and the jumper released. And that will be all for electronic components. Thank you and see you in the next episode.